Hello friends, welcome to iitians Gate classes. We are Bangalore-based institute and we run classes for almost all GATE courses like aerospace engineering, mechanical engineering, EC, electrical, instrumentation, computer science. So we run classes both online and offline, and during this pandemic we have switched to our online classes with recorded videos and live classroom. So with the huge success of our last batch for GATE 2021, we are ready with the next batch with more energy and improved contents. Right. So my name is Utpal and I am covering the core subjects of instrumentation. For instrumentation, we are having very less crisp and concise content on free sources like YouTube or some other uh, sources. So it's not easy for instrumentation students to prepare accordingly, right? So this is one initiative from our team to provide free content for this subject. So and apart from that, we have launched our full courses with comprehensive and exam oriented coverage of these subjects with PDF and PPTs. You will see these PPTs when I'm teaching. So PPTs, videos, and we are having test series assignments and everything will be there. And so please make best out of it and share among your friends. Okay, so today's topic. So today we are going to start our course on instrumentation, and the subject is going to be sensor and industrial instrumentation. This is the core subjects of instrumentation, right? So today we are going with the introduction, and here we will study all the sensors and signal conditioning circuit. First we will see the syllabus, and hope you are already aware of the syllabus. Okay, so this is the syllabus of gate instrumentation covering sensor and industrial instrumentation. So this is one of the subject from sensor and from gate instrumentation. And weightage, if I talk about weightage, then weightage is approximately 7 to 10 marks. So around 2 to 3 3 questions from 2 marks, and one or two questions from 1 mark used to come. This year also around 8, or I have not seen the question paper, but as per the feedback from the students, around 8 to 10 marks questions have been asked this year. Okay, so the content, how we are going to study this course, we will see all those sensors one by one: resistive sensor, capacitive, inductive, piezoelectric, and its signal conditioning circuit. So this is going to be important. Most of the questions are getting asked with the design of the signal conditioning circuit, and they are asking to find the output. So this signal conditioning circuit, it will consist of OM and all those things we'll see. We are having other sensors as well, like displacement, velocity, acceleration. So if I'm talking about this velocity, acceleration, force, or displacement, so these all are what? These all are the process. These all are the process, and this we want to measure. This process we want to measure. Okay, this year they have introduced 4 to 20 milliampere two wire transmitter. So this is a part of process control. This will be covered in this course also. Okay, so let's start with the very basic block diagram of instrumentation system. Yeah, so this block diagram you might be familiar when you are in college, or if you are in college, you might have studied or you will study these things. So the basic block diagram of instrumentation system, it will start with your input, and input is going to be true value. So what is the input? In the previous slide I told you, when we are going to measure the flow, when we are going to measure the pressure, when we are going to measure the temperature, then what is the process? So these all are the process are there, and these we want to measure. These processes we want to measure. Like say, if you are having a temperature sensor and you want to measure the temperature, so you have to plug your temperature sensor to a measuring device, like any tube in which some hot fluid is flowing. Then you will, let's say this hot tube is there in this you want to measure the temperature. So what you will do, you will put your sensor here. So this sensor will sense the temperature. So what is the temperature? Temperature is going to be the process, right? Temperature is going to be the process. Okay, so this part is done, and then we are having sensing element. So sensing element is nothing but your sensor. Sensor senses the process, right? As I told, we are having a temperature sensor, flow sensor, many sensors are there. So when I say temperature sensor, so this temperature is going to be process, and temperature and the sensor is going to sense the process, right? Next we are having another block in the block diagram that we call as signal conditioning circuit. These things we will see when I will take the example of one or two example of the process, then it will be very easy for you to understand these things. So as of now, understand that signal conditioning circuit is nothing but an element which will make the signal in a condition for further processing. So the name itself is like condition. So if the signal here is not in a condition to be further processed, what this will do, this signal conditioning block, it will take the signal, and it will do a certain operation, and then it will make the signal in a condition so that it can be processed easily, right? And what this constraint is there, I will tell you in by taking example. I will tell you, it's not easy to understand here, right? Next we are having signal processing circuit. So whatever the signal that we got here, the data that we got here, that need to be processed. So signal processing element is there. Then we are having the data presentation element. So whatever we have processed the data that we want to display in certain devices like CRO or monitor or anything, then we are going to use the data presentation element. And finally this is going to be the output that you want to see, right? So from where we have started with the process. And what the process was, the process could be temperature, flow, pressure, anything, right? And ultimately this all circuits we have used, and we have collected the data that what is the temperature here, what is the temperature of a particular process, or what is the flow rate of a particular process, or what is the pressure of the particular process, right? And we have collected our data in a display devices, right? If I talk about the examples of like what all blocks could be there, so I will take the three examples of process, then I will cover what all blocks could be possible in this. Like in sensing element, what all sensors could be there. In signal conditioning circuit, what all elements could be there. Processing circuit, what all elements could, like here it could be ADC, it could be DAC. In presentation element, what all could be there. And right, in signal conditioning circuit, what all elements could be there. Like here you can have your Wheatstone bridge, here you can have your op-amp circuit, here you can have your any other electronic circuit that will help in a signal conditioning circuit, right? So let's check the first example of process and the okay. So before that, why we are going to study these things, right? What is the aim behind this, in what is the aim behind the designing of your instrumentation system? So as I told, we want to convert our this process. So this process we want to convert into a known standard, which could be measured, which could be monitored, and which could be controlled, right? If any furnace is there and the temperature is 1700 degrees Celsius, you want to control. So so in order to control this, first you have to measure what is the temperature. Then only you will do some back tracing, like feedback control system to control this temperature, right? If it is risen to some plus 50 or minus 50 degrees Celsius, you want to maintain this, then at least you need to measure the temperature. Then you will do some feedback circuit, and then you are going to control this, right? So this feedback circuit, basically this all the part of your process control and analysis is done in the control system. Okay, so I'm taking the first example of temperature measurement using RTD. So what is RTD? RTD stands for resistive temperature detector. RTD stands for resistive temperature detector. And this is a sensor which measures, this is a sensor which measures temperature. So now you tell what is the process and what is the sensor. So the process here is going to be the temperature. This is going to be process. And what is the sensor? The sensor here we have used is RTD. So we are going to see how the temperature measurement is done using RTD, and then we will fit this diagram into our basic block diagram of instrumentation system. So let's take the sensor. Okay, so this is the actual RTD that you will buy from the market. So you can see here three wires are there. So these are available in three configurations, basically 2 wire RTD, 3 wire RTD, 4 wire RTD. So these all uh, this will not be covered here. When we study the temperature measurements, temperature sensors, RTD, thermistor, thermocouple, and pyrometer, everything, then I will briefly cover because it will take a lot of time to cover. In the full courses, these all things are covered. Okay. But anyway, I will give a brief overview. It will be easy to understand. So we have taken our first sensor, that is going to be the temperature sensor. So what it will measure? Definitely it will measure temperature. So this side, the process is going to be temperature. The process here is going to be temperature. So let's say the temperature is 40 degrees Celsius, right? You have used your RTD, and the output of RTD is going to be the change in resistance. Output is going to be the change in resistance. So let's say it's 20 ohm, and it measured the change in temperature as 40 degrees Celsius. What RTD did? So RTD senses the change in temperature, and it provided the output, and output is change in resistance, right? Now you tell what you will do with this change in resistance. This is not meaningful unless you are going to convert it into some quantity that is going to be either voltage or either current, right? So as I told, this is not in a condition for further processing. I repeat, this is not in a condition for further processing. This is so this change in resistance is not in a condition, not in a condition for further processing. So what you will do, you will place your signal conditioning circuit here. And what could be the signal conditioning circuit? Is there any element in analog or instrumentation which will take your change in resistance and convert to some either voltage or current? Yes, we are having Wheatstone bridge. You remember, this is the block diagram of Wheatstone bridge. This is the Wheatstone bridge. What it will do, it will take your change in resistance and it will convert to a change in voltage, right? So actual connection will not be shown here. So as you understand, you can understand that this is going to be RTD and the connection is like this, right? So and it will take the output from here. So let's say the output is going to be the change in voltage, change in voltage VOB, and let's say the voltage is going to be 40 millivolt. So this data is random. It may not be the correct or the physical data or actual data, right? So let's say the change in output voltage is going to be 40 millivolt. Now this is meaningful. Yes, this is meaningful because it's in the format of voltage or current, right? But you can see this is the voltage is very less, right? The its strength is very low, right? It cannot be processed. So it's still in a condition not for further processing. So still here, not in a condition, not in a condition for further processing. So what you will do, you will again find some element which will make it in a condition for processing. So now you got to in a voltage quantity. Again, you don't want to change into some other quantity, but you want to increase the strength. So what you will do, you will place some op-amp or amplifier circuit to increase its strength, right? So we have used here op-amp. Connection is not shown here, just for understanding we have used a block diagram. So again, let's say the gain is 10 or 100, so it will increase its strength or zero point 0.4 volt or 4 volt, depending on how it is going to be the what is the gain or and what is the V plus and V minus, right? So let's say here we got the 4 volt. So now you tell this is feasible. Yes, so here this data is in a condition for processing. We got in a voltage quantity, correct? Strength is good, yes. So no further conditioning is needed. Directly we can go for processing. So now we have to find certain elements that can process your this output quantity, right? So why we are doing this? Because ultimately we want to go for the display. Ultimately we want to go for the display. So for display we want the digital data. We want the digital data, and here the data is in analog format. So now you tell what could be the possible processing circuit. So the processing circuit could be your analog to digital converter, correct? So analog to digital converter is here, and finally you can connect it and you will get your digital data here, and then you can feed it to computer or any display devices to get your data, right? So from this diagram, what you understood, when you want to measure a process, you have to connect your sensor, and then it will sense. You have to make it in a condition for processing. If it is not, again you have to connect, then go for processing, and then go for display, right? So basically you can fit this into a block diagram of our instrumentation system that we have studied in the previous slide, right? So so this one example is done. We will take another example of thermocouple. So what is this thermocouple? Thermocouple is a sensor which will measure temperature. So now you tell what is the process and what is the sensor. The process here is going to be the temperature, and what is the sensor? The sensor is going to be thermocouple. Again we will start with our block diagram. What is the ultimate aim here? Ultimate aim here is go for the display. Here there could be any furnace or anything where you want to measure the temperature. So let's say the temperature is 1000 degrees Celsius, and you want to measure this temperature, and you want to display the temperature into a device. Here a control room is there, and you want to display the data. So for that you will use the sensor. So the sensor we are using is thermocouple, right? So this is a J type thermocouple, and so the range that it will measure, it will cover in the temperature sensor part. I have taken, just for instance, I have taken example as 1000 degrees Celsius. So what this will provide, the output will be voltage. See, again it provided the output as voltage. So is it a meaningful quantity? Yes, but its strength is not good. If you will measure, if you will measure with the thermocouple, so the output is going to be in the microvolt or very few millivolt, because its sensitivity is going to be uh, very less, right? So in that case, what you want to do, you have to go with the signal conditioning circuit, and you can put your op-amp here. I have not put any op-amp, so you can put your op-amp here, and so this I have taken an example of uh, thermocouple. So I have taken these two wires, wire type A and wire type B, and I am going to measure the temperature. So here you can go for the cold junction compensation. So this is going to be your signal conditioning circuit, because you remember in the thermocouple, or if you don't know, no problem. So in thermocouple, we want a reference junction temperature, and this is going to be the measuring junction. You want to measure the temperature with certain reference. Like if this is 40 degree, then this is 0 degree. So 40 with respect to 0 is going to be 0 degree. Okay, so we want a reference junction, and this reference junction always used to be at 0 degree Celsius. But there is one disadvantage, right? Due to variation in the temperature, ambient variation, or any could be, this is not stable. This we will study detail in our either full courses, or we will study briefly in our this crash courses. Okay, so this is not stable. In order to make it stable, we will go for the cold junction compensation. So cold junction compensation is there, then you will get your output voltage, and then again same process. In order to increase the strength, you have to go with the op-amp, then you have to go for this processing circuit, then you will go for the display, right? Third example is going to be your force or weight sensor. Now you want to measure the weight. So you want to measure the weight, what you will do? Sit on the or stand on the weighting machine. Stand on the weighting machine. So this is weighting machine, you have to stand here. So this is going to be sensor and your weight is going to be process. This is going to be sensor and your weight is going to be process, right? So I will move quickly because as of now, I think you understood the block diagram. So we have taken the force sensor with a strain gauge. So the detail of how this is designed will study in the strain gauge part, right? So the output is going to be change in resistance. This change in resistance you have to convert to change in voltage. Again, you have to apply to Wheatstone bridge, then increase the strength by adding op-amp. Then you will add the processing element, then go for the display. So what is the conclusion? We have started with the process. The input is going to be the process and output is going to be the data displayed. So if the process is, let's say, 10 degrees Celsius change in temperature, these 10 degrees Celsius you want to display here. So this is the measured value. This will not directly be 10 degrees Celsius. It will be calibrated form. So calibration we will study later. But as of now, you understand that this 10 degrees Celsius is equivalent to some data 0110. So this 0110 will be displayed here. So based on this, you can decode that the temperature is going to be 10 degrees Celsius. Right, so sensing element we have seen, conditioning circuit we have seen here, it could be op-amp or your reference junction compensation, like that. Processing circuit we have seen, data display we have seen, and finally this part is done. So what you have to do, you can take the reference of this book, that is JP Bentley, and you can study, make the notes of the sensor, what is the definitions, you can write the definitions of signal conditioning circuit, what could be the possible elements in the signal conditioning circuit, what could the possible elements in the signal processing circuit, what could be the possible element in the data displacement. This you will study from this book, right? I'm not covering in detail because otherwise video could be very long, right? So you can go with the self study. Now a brief coverage of what is the uh, content of the full course. We are starting the full course soon. We have already launched and admissions are going on. Comprehensive coverage is there for all the topics of sensor and industrial instrumentation. I am taking this, and we are having 60 plus hour lecture. Online lectures will be there. Recording will also be available. You can rewatch the recording according to your own time. Interactive session is there with limited students. We take classes online on Webex, and so the best part of my course is going to be 150 plus questions in the classroom. Yes, so 150 plus questions you are going to solve in the classroom itself, and only notes is sufficient for you to solve all the questions of GATE. Uh, uh, anyway, no one is certain, but at least you are able to solve 90% of the question, more than 90% of the question. And a one-to-one, definitely one-to-one mentor guidance is there, because we used to take less students. Means strength is uh, limited strength is there, so we can guide. Assignments is there on the at the end of each topic, and we are having weekly test and freely early test series, right? So please make best out of it and share among your friends. And if you want to join the full course, you can call on this number to talk to the management team. So thank you. Like, share, and comment. So next topic will be uploaded soon. Thank you.